Chapter 8, right triangles. Today we're going to cover section 8.5, the tangent ratio. Your class opener. 1. Draw and label right triangle ABC with C being the 90-degree angle. 2. Name the hypotenuse. And 3. Name the side opposite angle A. Today we're going to cover the tangent ratio. The objectives would be define the tangent ratio for an acute angle and solve right triangle problems by using the tangent ratio. First off, we need to know what opposite, adjacent, and hypotenuse are. So if you look at a right triangle, the side across from the 90-degree angle is always going to be the hypotenuse. So for the triangle here, B is going to be the hypotenuse. And then the opposite and adjacent vary. So here's where you have to be careful. If I'm talking about angle C, opposite is going to be C. And adjacent, which means next to, is going to be side A. But if you were to, instead of talking about angle C, what if you were talking about angle A? Well, if I'm talking about angle A, opposite means across from. So across from angle A is side A. And adjacent right next to it would be side C. So when we start talking about the tangent ratio, just remember, hypotenuse, always the longest side across from the right angle. Adjacent and opposite change depending on which angle you're talking about. So adjacent is the side next to, opposite is the side across from. So the tangent for an angle. The tangent of angle A is the leg opposite angle A over the leg adjacent to angle A. So if I look up at my triangle up here, if I'm talking about the tangent for angle A, it's going to be the side opposite angle A over the side adjacent to angle A. Or sometimes we just say tangent is opposite over adjacent. And sometimes we even just shorten that up to TOA, tangent equals opposite over adjacent. So if I was looking at the problem up here, I could say that the tangent of angle A is the opposite side A over the adjacent side C. Express the tangent of R as a ratio. Well, here's how I remember TOA. Tangent is opposite over adjacent. So the tangent of R is going to equal the opposite. Well, the opposite is 3 over the adjacent, which is right next to it, 8. And 3/8 doesn't reduce, so it's 3/8. Now, some of these are going to ask us to find the decimal values for various things. So if I wanted to say find the tangent of a 6-degree angle, I would look at 6 degrees. I'd skip the first and second column, which are sine and cosine, and go to the tangent. So the tangent of a 60-degree angle would be 0.1051. Or if I asked the reverse and said, if the tangent of some angle is 0.4, what's the angle going to be? Well, then I would just start scanning through the tangent column until I found the closest decimal to 0.4. Well, here's the closest decimal I have to 0.4. So if the tangent is 0.4, that's going to mean it must have been a 22-degree angle. So when you get to problems like these, what's the tangent of a 24-degree angle? You can either look up the chart in your book, find a 24-degree angle, and look for the decimal value that is associated with it. Or if you get your calculator out, as long as you make sure that it's in degree mode, you can just type in the tangent of 24. And depending on your calculator, some of them you hit the tangent button and then 24. Others you hit the 24 and then the tangent button. On mine, I type in 24 and then just hit the tangent button and I get this decimal. And if we're doing it with the calculator, we're going to round them off to 4 decimal places so it matches up to anybody who's using the chart. And it looks like I would write 0.4452. Now, the next part, the tangent of what angle is 2.4751? Well, if I don't use my calculator, I go back and I look in the tangent column for 2.4751, and I scan down until I can find that. and I notice that here's 2.4751, which means that it's going to be a 68-degree angle. If I don't want to use the table, I just grab my calculator, and I have to hit the shift or second button. So I'm going to type in 68, shift or second button, for which means in the upper left. And you should notice a button on your calculator that's probably tan and has this -1. That's the button you want to hit. It's going to tell you the angle measure that's related to a certain decimal, and I typed in the wrong decimal. I need to type in the 2.4751 and then hit the second tangent button, and it gives me roughly a 68-degree angle if I round it off. Find the value of x to the nearest 10. Right. Well, here's what I notice. I have two different angles. I'm going to just pick one. I'll pick 32. And I notice if I pick the 32-degree angle that x happens to be opposite from it, and the 22 happens to be adjacent. And I know that if I write down that the tangent of 32 degrees equals opposite over adjacent, that would be x over 22. Well, I'm just going to set this up as a problem to cross multiply. So now I need to know what's the tangent of 32 degrees. So I grab my calculator, I type in 32 degrees, hit tangent, and I'm going to use 4 decimal places, 0.6249. So 0.6249 equals x over 22. If I cross multiply, I get x equals, so 0.6249 times 22. 0.6249 times 22, and I get 13.7478, and I'm just going to round that off to 13.7 since the directions wanted the nearest tenth. Right. Find y correct to the nearest degree. Now when I look, I don't know y, but I do notice that the 6.1 is opposite. The 4 is adjacent. So knowing that tangent is opposite over adjacent, I have the tangent of y degrees equals opposite 6.1 over adjacent 4. Well, I want to see what 6.1 divided by 4 is as a decimal. So I get my calculator back. 6.1 divided by 4 is 1.525. And now if I want to know what angle that's associated with, I either look that up in the chart or back at my calculator, I'm just going to hit second tangent, and it tells me that if I round to the nearest degree, that this is going to be a 57-degree angle. Find w, then z, correct to the nearest integer. First thing I notice about this triangle is the fact that it's an isosceles triangle, which means that since there's a 42-degree angle at the bottom, the angle up here at the top is also going to be 42 degrees. The next thing I notice is that if I have an isosceles triangle and I draw in the altitude, the base ends up getting cut in half. So this w is just going to equal half of the entire base, which means that w is 60. Okay. Now I'm going to look for finding z. Well, I know for my ratios, if I have this 42-degree angle, that z is opposite, w is adjacent. So if I set up my tangent, I get the tangent of a 42-degree angle equals opposite z over adjacent 60. And now I'm going to set this up as a proportion. So I need to figure out what the tangent of 42 degrees is. So I go to my calculator and I type in 42 degrees, hit tangent, and I get 0.9004. So 0.9004 over 1 is going to equal z over 60. And if I cross multiply, I'm going to get z equals go back to my calculator again, and I type in 0.9004 times 60, and I get 54, and we're rounding to the nearest integer, so it's going to be 54. In your closure, what is the main idea of today's lesson?